Good morning, and thanks for joining today's broadcast, Developing Highly Performant Applications Using CRDT-Based Active-Active Redis Enterprise. Our presenter today is Roshan Kumar from Redis Labs. Today's broadcast is being recorded, and all attendees are in listen-only mode. During this broadcast, we will be taking questions. You can post your questions using the question and answer module in the communication panel. Your questions will be answered in the order they are received during the Q&A session. Following today's broadcast, an email will be sent with a link to the recording to you for your future viewing and to share with your colleagues. And now we have Roshan.
Hello, everybody. Good morning, good evening, or good afternoon, wherever you are. Thanks for joining for today's webinar. We have a very interesting topic. It's about active-active CRDT-based Redis Enterprise. There is a tremendous interest in the market about active-active databases, and we are getting a lot of questions and a lot of interest about this topic. But the main focus of today's webinar is how to develop apps on top of active-active Redis Enterprise. We have a lot of material on what is CRDT-based Redis Enterprise. I'll give a very quick overview. I'll spend about 5 minutes, the first 5 minutes, about Redis Enterprise and what is CRDT for. If you're new to CRDT, I'll give a quick overview of what this concept is. But as I said earlier, the main topic for today's discussion is how to design an app, how to develop an app, and then how to test it. And also I'll give you some nuggets on how to set up your own environment for developing and testing. And also I'll do a demo. It's a very easy demo, and also point you to all the source code on GitHub. So all the scripts that I'm going to show today and all the programs that I'm going to show today, they're all on GitHub. You can go and you can download them, and you can play around with them. Okay. And then if you have any questions, please post your questions. I'll take all the questions towards the end. And if you have any questions in the middle, just don't wait until the end of the webinar. Please post them as you get them. Fine. Okay. About active-active geo-distributed databases, there are a few vendors who support active-active databases, and what we have seen is there are two main problems with active-active databases. The first one is latency, and the second one is conflict resolution. It's a bit ironical because the very reason why people go with active-active databases is to avoid latency. The reason they go for active-active databases in a geo-distributed world is to avoid the round-trip latency, and they want to have local latency. So they deploy their app very close to the database and avoid all the network latencies in between. However, we will see that in the next slide that latency is still a problem with many active-active databases out there in the world. And the next problem is conflict resolution. You may argue that conflicts happen 1 in a million times. It's very unlikely that there's going to be a conflict, but we have seen in the field that there could be conflicts, and there are many use cases where conflicts are more common. And what we have seen with the traditional databases is either the conflict resolution is not handled at all, or if it is handled, it requires some operational support, and it becomes more expensive in a long run. Okay, so the first problem, as I said, is latency. Again, to repeat the same thing, the very purpose of a geo-distributed database is to avoid the network latency. You want to deploy your app as close to the database as possible. However, there are two types of consistency models in active-active. This is the traditional approach. One is eventual consistency, where you write to the database, the local replica, and all the replicas, somehow they ensure that the data is consistent eventually. One popular technique here is quorum-based consensus. Cassandra, DynamoDB, they all use quorum-based consensus. And a typical latency you see here is about 100 milliseconds. You may think 100 milliseconds is not much, but when we're talking of millions of ops per second, 100 milliseconds is really a long time. Now, in case of strong consistency, the latency is worse because all the replicas, they need to agree to any changes you make to the database. So they all need to sync before they get back to your app. So you see a latency of something like 200 milliseconds, which makes your situation worse. Now, the second problem is conflict resolution. As I said earlier, it's hard to manage conflicts, even if they occur 1 in a million times. And we have seen many solutions that use app-level conflict resolution. So what they do is, if at all there is a conflict, they write a tool or a wrapper at the application layer that will go and look at all the data. And if there is any consistency, they develop some logic, or they do some manual conflict resolution. So the problem here is, of course, it doesn't scale. And then another technique for conflict resolution is last write wins. There are a few database vendors that do last write wins. The idea here is, if you update the same record at 2 replicas before they sync up, you maintain a timestamp of when the update happened. And when the data syncs, you look at the timestamp and you make a decision. The update that happened at the later point of time is the right data. So you resolve the conflict that way. The problem there is, first of all, you need to have all the clocks in sync. And then the second problem is it doesn't work well for all the data structures, especially if you're using Redis data structures. There are better conflict resolution techniques, and we'll discuss those techniques in a while. Right? So with that said, Redis Enterprise supports CRDT-based conflict resolution. So it is a CRDT-based database. And with this, you get strong eventual consistency, and your latency is reduced to less than a millisecond. So if you develop apps, you deploy your apps closer to Redis Enterprise Replica, and all the latency you have is the latency between the network latency that's between your app and the database. That's the local latency. And it's a very interesting way to deploy your solution. And with this, you get a very highly performing application. And if you are building a highly collaborative application, this is the way to go. And also, in case you have a geo-distributed application and you want to have a geo failover solution, this is the way to go. We have a lot of customers who have deployed active Redis Enterprise for the sake of geo failover. Right? Now, when it comes to conflict resolution, many of you may know that Redis has some built-in data types or data structures. Now, every data structure has its own property, and we have built, when I say we, Redis Enterprise, the Redis Labs product, we have built all the conflict resolution that goes with the data type itself. For example, if you have counters, we don't need to do last write wins. We'll do a conflict-free merge. And similarly, for sorted sets and sets, we have a lot of conflict-free merge techniques. I'll do some demo later on. Okay, now how does the CRDT work? First of all, what is CRDT? CRDT stands for conflict-free replicated data type, and there's plenty of material on the internet. It's an academic paper that was published in 2011, and there are quite a few databases that have CRDT support. Now, in a CRDT, a data type has one of the 3 properties: commutative property, associative property, or idempotent. Now, there are few CRDT examples that are published in the paper, and what we have done in Redis is we have taken these examples and used them for conflict resolution with Redis data types. Right? Now, here is an example of a counter. Now, let's say there is a record K, and at one particular time T1, you update this record, you increment. Now, this is a counter. So you increment this counter at 3 different data centers across the world. Let's say you increment this counter by 40 at data center A, and by 30 at data center C, and by 50 at data center B. Now, with last write wins, what happens is you record the last time, and you update the counter to one of the 3 numbers here. But in reality, what you're doing is just counting, and what you want is a strong eventual consistency that goes to the same number. Here in this case, it is 120. Here, as you see, A plus B is same as B plus A. So counters, they show commutative property and also associative property. So it's easy for us to do a conflict-free merge. Similarly, with the set, here I'm showing an example of distributed caching where we are trying to cache some of the images. Let's say we are adding Wonder Woman at data center A. Remember, all these things are happening at the same time, T1. And we are adding Star Wars at data center B, and we are adding Star Wars again at data center C and Coco. Eventually, when all the replicas exchange all this data, the set will have just 3 objects. Now, Star Wars is a duplicate, and because of the strong eventual consistency, you won't see the duplicate in the set data structure. Right? Now, Redis, as I said, Redis Enterprise supports active-active setup, and it is based on CRDT. And there are many advantages of using Redis Enterprise for active-active as an active-active database. First of all, performance. Redis Enterprise is built on top of open source Redis. It is compatible with open source Redis. And as many of you know, Redis is a very fast in-memory database. It has the least latency, so you can perform millions of ops per second, and you're getting sub-millisecond latency for each operation. And also, Redis has built-in data structures, so that's to our advantage. So we just take these data structures and make them conflict-free. And then there are about 60 plus languages that have Redis clients. So if you have already developed an application using open source Redis, then it's likely that you're already using some open source Redis client. The good news is, if you are transforming your application to support active-active Redis Enterprise, you don't have to change your libraries or how you use Redis data structures. It's going to be the same. So you can use the same libraries that are available, and they work really exactly the same with Redis Enterprise. And with Redis Enterprise, you get geo-distribution with local latency. As you see here, Redis Enterprise has many more features built on top of open source Redis. It helps you scale. It helps you with linear scaling. It helps you with geo-distribution. And there are many, many things that come with Redis Enterprise. And it can manage all conflict resolution if there is any conflict. Right? So that is the introduction about Redis Enterprise and its active-active support using CRDT technology. Now, the main portion of today's webinar is how to develop apps using Redis CRDTs, and we will walk through the 6 steps. So this is the main purpose of today's webinar. I'll show you how to set up a local environment, a dev and testing environment, and also we'll see some examples of how to do that. So in a nutshell, we talk about 6-step design. The first step is you need to understand Redis CRDTs and how the conflict resolution happens. I'll show some examples, and also on our website we have a detailed documentation of how the conflicts are resolved and how each data structure handles conflicts. So that's something you need to know before you start designing your application if you are designing from scratch. And the second thing is you need to identify CRDT compatible use cases. Again, the point here is CRDT-based data structure could be good for some of your use cases, but if you're building a payment, if you're looking for a payment platform, you may want to use some other database and not really CRDT. So there are some use cases that work really well with CRDT-based database, and there are some use cases that may not really work well with CRDT. So that is something you need to identify, and we'll see some examples here. And step 3 is to understand the best design practices. I'll present some caveats, and also I'll talk about some of the best practices. So if you're designing a solution from scratch, how do you start, and how do you design your solution so that it handles all the conflict resolution that happens in the background. Right, and the fourth step is setting up your development and test environment. I'll give you some scripts, and it's easy. I'll make your life easy. So all you have to do is just run those scripts in your environment, and that will pull all the images, Redis Enterprise images from Docker Hub, and it will set up a development and testing environment for you. I'll show you how to do that. And then once you develop your app, now your app must be resilient for any network failures. That's one of the good parts of working with active-active databases, because the database in the background manages all the conflicts. So your app need not worry about syncing all the data and everything, but still you should have enough use cases that test your application when all the replicas are connected and when the replicas are not connected. So I'll show you some examples. Also, I'll provide you scripts that will help you split the network and connect the network and run all your tests. And lastly, I'll do a demo and show you how to develop an application. I will show you a web application, a very simple web application using Node.js. I'll walk through the code and show you how you can develop a very simple application, a counter application on top of active-active Redis Enterprise. Okay, so let's start. First of all, understanding Redis CRDTs. Many of you may already be familiar with Redis data structures. So Redis has built-in data structures. It has strings, hashes, sets, sorted sets, and lists. Each of the data structure has its own way to manage conflicts when it comes to active-active environment. So in Redis Enterprise, we have designed Redis Enterprise in such a way that it has the conflict resolution techniques that are appropriate for these data structures. So we'll see some examples. For example, when it comes to conflict resolution, we have a few types of conflict resolution techniques. First one is conflict-free merge, and we have last write wins for some of the data structures like strings or registers. That's what we call them. And also we have some conflict resolution techniques for add or update wins over delete. So let me do a very quick demo. And before I do a demo, let me start the script here. Let me. So you may be seeing this here. So I'm creating a local environment on top of a Docker. So this script is now going to download all the binaries it requires to set up Redis Enterprise, and it will set up 3 nodes for Redis Enterprise, and each node has a cluster. I'll walk through this setup in a few minutes, but while we wait, I'll go back to the presentation. So if you take this example for conflict resolution for the first one, I'm doing an sadd. Sadd is set add. So I'm adding an element A to key 1, and at the same time, I'm adding element B to the same set key 1, and I'm adding element C to the same set key 1 at instance C. So all these things are happening in parallel, and when Redis Enterprise syncs up, this set key 1 will do a conflict-free merge. It will add A from instance A, B from instance B, and C from instance C. So eventually, you have strong consistency here, and all the replicas will have A, B, C as the elements of key 1. So I'll show an example in a while. Now, in case of last write wins, this is a case of a register. We are setting value 1 to key 1. So this is a string data type. And at T2, we are setting key 1, the value of value 2. And when they synchronize, and now this is assuming all the clocks are in sync, now Redis Enterprise will vote for which is the right one, whether it is value 1 or value 2, and it makes a decision that all the replicas must have one consistent value. And in this case, it makes a decision based on the timestamp, which in this case is value 2. Now, in case of add and delete happening at the same time, add or update wins over delete. In this example here, I'm setting hello to key 1, and I'm doing an append here at time T3. But at the same, around the same time, before the sync happens, there is a delete happening at instance B. Now, Redis Enterprise must make a decision on whether to whether to run append command or whether to run delete command. And because of the rule add or update wins over delete, Redis Enterprise makes a decision that append wins over delete, and it will keep the value hello there, and it will ignore the command delete. Okay, by now our instances must be ready, so they're all up and running. You can see. I'll do a quick demo here. So in this case, I have 3 instances of or 3 nodes that have Redis Enterprise. You can just for the sake of this demo, I'm calling one node Atlanta, the other node London, and the third node Rio. And each node is running on a separate port. The first one is on 12,000, the second one is on 12,002, and the third one is on 12,004. So I'm going to connect to each of the replicas, and if I get the value of counter, you'll see it is 0. So there's nothing in here. Now, just make a guess what happens if I do an increment on counter. So remember, there's an increment happening at all 3 places, Atlanta, London, and Rio. The hypothesis is the eventual answer will be 3 because it is 1 plus 1 plus 1. So let's see what happens. So when I do an increment counter at each location incremented the counter by 1. You see that here. And when I do get counter, you'll see the value 3. So that's the conflict-free merge. Now, similarly, I can do an S add. I'll call it my set. I'll call A, B, C. So I'm adding A, B, C at Atlanta. And what I'll do is I will add B, C, D at London. And then I'll add D, E, F in Rio. So eventually they should all have just A, B, C, D, E, F, and there should not be any duplicates. So let's see what happens right now. So let me execute that. So if I do S members, my set, so you can see that they have the same set of elements, A, B, C, D, E, F. So Redis Enterprise did a conflict-free merge. So you can play around with many more examples. Another example, this will be the last example. I'll show how the list works. In case of list, there is no uniqueness in a list. So if you add the same item at different places, you will have duplicate items. So let us see how that works. So if I do L push my list, and I'll just say 1, 2, 3. And your hypothesis here is you'll see a total of 9 elements in the list, and you'll see duplicates of all 1, 2, 3. Okay. So I added 3 elements at each location, Atlanta, London, and Rio. And if I do range my list, and I'll just do 0 to 100 just for that. So let's see. So you have 9 elements. So that was the hypothesis. And also, in case of list, you can see that the order is maintained. In case of set, the order is not really important. But in case of list, all the lists across all the regions, they maintain the same order. Okay, so these are some examples of how CRDT works, and you can play around more at your own pace. Okay, and also in case of PubSub, there is also PubSub support. We have a few customers who asked us about this. So we do have PubSub support. The idea here is I can, for example, I can subscribe, let's say here at London, I'll subscribe to the news channel, and even at Rio, I'll subscribe to the news channel. Right, and if I publish to news here, so I'm publishing news. So this is PubSub. So I can just say hot news. I'll just say hot news. And all the replicas across the world, they will all receive this message. So there is a PubSub support as well. And also another question we constantly get is, well, what about the time to live? Now, Redis has this unique feature where you can expire the keys. So you can expire a key, for example. Here in this case, key 1, you are setting the expiration in 10 seconds at instance A, and you are setting it to 30 seconds at instance B. And when the 2 instances, when the 2 replicas sync, the largest time wins. So in this case, the 30 wins over 10. So the key will remain for 30 seconds. And if at all you set a -1, which means the key should not expire at all, which is the default value, then that will win over any other number. Right. So these are some of the basic things you need to know before you design a CRDT-based solution. Right. And then some of the next step. This is step number 2. There are some use cases that work with CRDT, and there are some use cases that don't work with CRDT. So if you're designing a solution from scratch, make a list of all your use cases and list out the use cases that work well with CRDT and the use cases that are not compatible with the CRDT-based database. For example, financial transactions, you still want to use a traditional database. Or if you want to manage order processing and fulfillment, you may still want to use a traditional database. It may be geo-distributed or it may be centralized. So maybe it's a centralized database. But there are many other use cases like leaderboards or counters or user activity tracker, session store, inventory management. There are many, many use cases that will help you with highly collaborative apps. You can build highly collaborative apps using Redis Enterprise. Right? And then the third one is you need to know the best practices. There are some caveats. One question that commonly comes is, what happens if there is a conflict? Will the app know that there was a conflict? The answer to that is no. All the conflicts are resolved in the background, and the app will not get any notification if there is any conflict. And also the apps cannot override any default conflict resolution semantics. The conflict resolution semantics are already defined in Redis Enterprise, and we have already chosen the right conflict resolution semantics for that data structure, and you cannot override the default semantics. And also, one question we hear is, what about Lua scripts? Now, Redis has something called Lua scripts. It's like stored procedures. Now, if you call a Lua script at one replica, does that result in calling the same Lua script at another replica? So that is a question we hear all the time. And the answer is no. We don't call the same Lua script at another replica. However, inside the Lua script, if you are running any commands to access the CRDTs or to update CRDTs, those commands will be replicated on the replicas. So we synchronize the commands inside Lua script, but we don't synchronize the calling the Lua script itself. So these are some of the caveats you need to keep in mind. And from this, you build some of the best practices. First one is make your app stateless. Now this is a growing trend. More and more apps are now stateless. They don't store any state in the app itself, especially if you're building a cloud native application. You should make your app stateless. It should support something like REST protocol, and then let the database handle all the state of the data. And also, when you design your solution, don't assume that there won't be any conflict at all. Just keep in mind that there may be conflict, and when you design a solution, bear that in mind, and that the conflicts may happen. Right? Okay, now the most interesting part. How do you set up your development and testing environment? I already ran a script that I showed for a short period of time. But typically, what you do is you develop your app, and then you deploy your app, and your app will talk to, in this case, local Redis instance. And if you're having a Docker instance, if you're having Docker set up on your inside your development environment, you can do a Docker pull Redis, and that will already have Redis, and you connect to the Redis on Docker instance. But in case of active Redis Enterprise, what we do is it's the same concept, but instead of deploying one app, we ask you to deploy multiple apps. The idea here is you are trying to simulate the global deployment. So what is a global deployment here? The global deployment here is you have a Redis node in each location. Once again, we are simulating this. When I say each location, here we are creating a subnet. So each Redis node is deployed in a separate subnet, and they're exposed through different ports. And internally, we connect these subnets whenever we want, and we disconnect these subnets whenever we don't want them. If at all you want to test your app on how it works with a split network, you just disconnect these subnets, these routes. And these are all deployed on Docker. How to do that? I will show how to do that, but I'm sure you're getting an idea here. You're developing the app, it's the same app, and instead of deploying one instance, you're deploying 3 instances, and each instance connects to a different node of Redis Enterprise, and each node has a cluster of Redis Enterprise, and we are deploying a Redis Enterprise active database that spans over all the 3 nodes. So this is the setup that we have, and how you do that. First of all, install Docker, and assuming that you already have Docker, first thing is you have to increase your memory, because it takes a bit of memory. So make sure you have at least 6 GB. That's what I have on my machine. So increase it to 6 GB. And then go to github.com/RedisLabs-demo. And there you'll find Redis CRDT Docker scripts. And there is a script called create 3-node Redis CRDT.sh. And what it does is it downloads all the images from Docker Hub, and it deploys them, and it creates 3 clusters in each node, and then it creates a conflict-free replicated database, Redis database with CRDT support. And with this, you get, going back to the previous slide here, you get 3 nodes of Redis Enterprise. They're all connected to each other with an active database, and each node has a separate port, so you connect through different ports. So that's how you do it. It's very easy, so you can just go and you can download and you can run by yourself. And I already did that here when I did the demo here. So it just runs here, and it creates new subnets, and then it starts all the Redis Enterprise and Docker, and it creates new cluster and so on. Right? So now in a couple of minutes, I'll show you how to develop an app in this environment. But before that, I have just one more important thing to show. So you need to, when you develop your app, you need to test your app when the databases are connected and when the databases are not connected. And your app must be resilient to both the cases. So we'll see how to do that. So if you go to the same GitHub repository, I have two scripts. I have split network and restore network. So if you split network, it will disconnect all the routes between the two subnets, all the three subnets, and restore network will restore all the routes. So you can run that and you can test this. And also keep in mind, there's a disclaimer here. These scripts are for development and testing only, and these are not meant for production deployment. These are just to make your life easy. Right? Okay, now you need to develop and test your application. I'll do a quick walkthrough. First, I'll do a demo of what I have built, and then I'll do a quick code walkthrough. I have a Node.js app. I built a Node.js app using all these libraries. I'm using Node Redis to connect to Node, and I'm deploying my Node.js app on 3 different ports, 3000, 3002, and 3004. And each instance of this app connects to a different instance of Redis Enterprise, a different node of Redis Enterprise, and we'll see how this works. So they're all running here. And also there is the source code. You can go to github.com/redislabsdemo/Redis CRDT demo. Right? This is a very small program. You can just download that and run it in your local Node.js environment. Okay, so let me do a quick demo. So here in this app, it's a very simple app. Before I have this, let me start. I forgot to start the application, so let me start the application. So let's do this. Let's split the network first before we, just for the sake of understanding how the stuff works. I want to split the network and do a demo of how it works when there is a split network. So I'm starting Node.js. The first one at Atlanta, I'm starting the app on port 3000, and in London I'm starting with 3002, and at Rio I'm starting with 3004. So now the app is coming up. Okay, all the apps are up. So I'll go back to here. So let me reload Atlanta, London, and Rio. So I have 0 votes for each of the dogs. And these are all the dog pictures I got from my colleagues. We have many dog lovers in my team, and these are all the dogs of my colleagues. And they're very cute. And so I thought of using them for the demo. So at Atlanta, let's say we want to vote for the best dog here, and I choose this. And you can see I incremented this by 5. So the white colored dog got 5 votes at Atlanta, but you don't see that happening in London because right now I have disconnected Atlanta from London and Rio. This may happen in real time because of network latencies or some network issues. And same here, let's say I increment this by 5 here or more, and then I vote for other dogs too in London, and I vote for the other dog in Rio. So let's see what happens if I restore the network here, or when I connect the network. You can see all the sites. They all now have synced up the data, and all of them have the same number, or they eventually will have the same number. Yeah. Okay. And same thing here. Now, if they're connected, it's easy. The number increases on its own. So I'm just incrementing the number on the first dog, and it automatically goes to all other places. If you want to test out, if you want to see how this works, you can just deploy this in your local setup. It's very easy. So if you go to the GitHub, github.com Redis Labs demo, Redis CRDT demo, what you get is this set of JavaScript files, and it's a Node.js application. So in server.js, as you see here, I have Redis, and I'm using socket.io so that I can send the message back to the app, back to the web application. And I'm using 2 Redis clients here. One instance is to fetch data from Redis or to write data into Redis, and the other one is for PubSub. I'm using as a subscriber. And you can do a quick walkthrough of the code. And in the routes, I have one for increment count and one for get count and one the default. And I'm using EJS as the template to build the HTML. So here is the EJS file, and you can find that on GitHub too. So the whole thing is on GitHub. So this is a simple demo of how CRDT works. Right? And you can extend this app. And if you're interested, you can build a leaderboard, or you can have an app that collaborates. You can have some shared sessions. You can do something like Google Docs does. You can have multiple people edit the same stuff. You can add same thing. Let's say you want to build a wedding registry. You want to have everybody add things to your wedding registry and collaborate, adding things into your wedding registry. Let's say you want to build that kind of an app. You can do that using this framework. Or if you want to collect data from multiple regions, you can do a data ingest. So each hub can kind of collect data on its own, and because of CRDT, you can merge all the lists and sorted sets. And also you can do distributed caching. This is a common use case, and so on. So there are many, many use cases that you can implement. So just to recap, we did a quick introduction of Redis Enterprise, and we talked about CRDT, conflict-free replicated data type, and we talked about Redis CRDTs and best practices to design your app. And also you saw the demo. You also saw how to deploy Redis Enterprise in your dev and testing environment. And if you have any questions, you can always get back to me. I'll give you my contact information. So that is the topic for today's webinar. And now I'll take some questions. One question is active-active available in open source Redis? The answer is active-active support is offered by Redis Enterprise, and Redis Enterprise is built on top of open source Redis. So one part of this question is open source. I'm assuming one part of the question is active-active compatible with open source Redis? The answer there is yes. However, active-active is not available with open source Redis as of now. It's available only with Redis Enterprise. And then, another question was, how are you typing commands at the same time? Are you using some kind of a terminal multiplexer? Oh, no. What I'm using here is, okay, the question is, how can I use the same command here? So I can do it using something called iterm2. This is a Mac application. So here, if I do Command Shift I can synchronize multiple sessions at the same time. And let's say if I do Command Shift I, it comes out. I'm just giving a demo here. So here I'm coming out. And if I do Command Shift I can synchronize all my sessions, and I can do a clear, it goes up, and I can do ls, and so on. So I can synchronize everything. So I hope that answers your question. And the next thing is, what is latency? Does it depend on geolocations and network? And does Redis have different approach to reduce latency? Now, latency comes in many parts. Most common latency is the network latency. Now, latency is the wait time. One analogy is, let's say you take a sports car, high-performing sports car in a freeway or an autobahn, then you have no latency at all. But if you take a sports car in a busy road with a lot of traffic lights, you are stopping at every traffic light probably, and you're just waiting for your chance to go forward. So even though you have a high-performing car, you may deal with latencies that are not in your control. So that's an analogy, and that's what we're dealing with most of the time. In case of network latency, one thing is the distance between your app and the database itself. If they're in the same data center, then you don't have so many hops, and you can reduce your latency. But if they are in totally two different regions and different parts of the world, there is always a wait your application will have to make whenever it writes data or whenever it asks for some data. So that is the latency we mostly talk about. Do you have separate cluster for each geolocation in your example, or just one Redis node? Now, in my example that I showed here, I have a separate cluster in each geolocation. I believe you're talking about this kind of deployment. Yes, I have a separate cluster in each, but in the real world, the way you deploy is you deploy multiple nodes in each region, and in each node you'll have primary and secondary servers for failover, and you have active instances across all the regions. So this is the typical production deployment, and what you see in my demo is only for development and testing. So you don't have primary and secondary in each location. You have only one cluster with primary. Whereas in real world, you'll have primary and secondary in each location. I hope that answers your question. And the next question is, what configuration changes are required to set up active-active? We have very good documentation on our site. Once again, active-active setup is available in Redis Enterprise. So I recommend that you read the documentation. It is very easy to set up active-active database. All you need is multiple nodes, and you need to create a database at each node and connect them as active-active databases. It's easy. You can do that through GUI, through our user interface that goes with Redis Enterprise, or you can do that with command line. What I showed you in the demo is a command line tool. Is there a procedure to set up this Redis cluster with active-active on Kubernetes? Well, there's one thing here. Redis Enterprise supports Kubernetes orchestration, so you should be able to do that. And if you run into any issues, feel free to contact us. So we have Kubernetes support, and we have quite a few customers who are using Redis Enterprise on Kubernetes, and there's a lot of interest in this area. So if you have any questions, feel free to reach out to us. Does your test stub support setting an artificial latency between clusters? Oh, very good question. I don't have that right now, but if there is a way to do that, please let me know. What I'm doing is very simple. I have different subnets on Docker, so I create different subnets on Docker. If there is a way to introduce latency between these subnets on Docker, I appreciate it if you can let me know. I personally, I don't know how to do that. So if at all you know, or if at all anybody knows, feel free to share that information. Does it support on top Redis data type, re-JSON or Bloom filter? Okay, the question here is, do we support, or does active-active support some of the Redis modules like re-JSON or Bloom filter? Right now, we don't have that support. Redis active-active support is available only to the data types that I showed you a short while ago. So these are the data types that are available with CRDTs: strings, hashes, sets, sorted sets, and lists. But going forward, that is something we have in our product roadmap, and we would like to see more data structures come into the realm of CRDTs. Can I create active DB model using replica of feature? Very good question again. In a replica of feature is a feature where you have only one active database, and you can have multiple replicas, and the replicas are only read-only, so you cannot write to a replica. It's a read replica. So if you have a replica of, or a read replica in your deployment, you still have to write to the central database. So in a nutshell, it is active-passive deployment. It's not an active-active deployment. But if you have read replica deployment, we can modify your deployment and make it active-active. It is possible to do that. But just with the existing setup, you cannot use it as active-active. Can we set active-active just for a particular database, or it has to be at cluster level? Oh, very good question. Now you can do that at the database itself. You don't have to do that at cluster level. What that means is you can have many databases on a cluster itself. You don't have to associate. There is no one-to-one mapping between cluster and database. So you can have multiple databases on a cluster or on a set of nodes. Can you show an example of sorted set conflict resolution? Yes, sure. I can set. Let me do a quick time check here. Yeah, we have 5 more minutes. So let me do a sorted set. Okay. Okay, so let me connect back to Redis CLI. I hope you can see my screen. So in a sorted set, the command we use is zadd. So when you do zadd, you're adding things to a sorted set. So I'll call it just SS for short, and then I'll add things to this sorted set. Let's say I'll add 10, and then A, 20 B. So I'm doing this on the first data center at Atlanta, and in London, I'll add 30 C and 40 D. And then in Rio, I'll make it 50 E and 60 S. Or yeah, I'll make it, I'll create some confusion here. So let's say I'll make it 40 D again, and then 50 E. Okay. So sorted set assures you that there is always a unique set of keys. So what happens here is you are trying to add D twice, and Redis Enterprise will resolve this conflict, and it will allow only one D. So again, once again, let's give a separate score for the other D here. So let's call it 60, and there is one D with 40, and the other D is with 60. And let's say I'm adding this to the sorted set. So I have added 2 elements, A and B, and I have added 2 elements, C and D, with different scores, and I have added D and E. And one thing you have seen here is D has the score of 60 at Rio, and D has the score of 40 at London. Redis Enterprise knows that there is a conflict here, and it will choose one of the two. So let's see which one Redis Enterprise has chosen here. So I will do a Z range SS. Oops, I'll do with scores so that you can see the scores. Okay, I have A 10, B 20, C 30, and D 40. So Redis Enterprise chose the one with 40 and not the one with 60. So it resolved the conflict, and then it chose E because E was anyway, it was added only at Rio. There was no conflict. There's one interesting thing here. I can do a Z incr by. If you know Z incr by, I can increment just for a member. Let's say I will increment by 5 for A at Atlanta, and then I'll increment by 10 in London, and I'll increment by another 5 in Rio on A. So A already has the score of 10, and now I'm incrementing that score by 5 in Atlanta, by 10 in London, and by 5 in Rio. So now I'm adding 20 eventually, so it should be 30. So let's see what happens. I'm adding this. Okay, and so let's do I'll do Z range here with scores. You can see here, where is A? A is now with 30 as our hypothesis, stands. Right? So hope that helped with the example. And we have one more question. Can I persist data with active-active? Yes, you could persist data with active-active, and we encourage you to use the snapshot technique and not the append-only file technique. There's nothing wrong with append-only file. It's just that you'll write a lot, and that may slow down your system. So a recommended way to persist data is through snapshotting. Right, and I think that's it we have for today, and I'll hand it back to Jean.
Great. Thanks, Roshan. On behalf of the entire Redis Labs team, thank you for joining us today. We're at the end of another broadcast. An email with the link to the recording will be sent to you for future viewing and to also share with your colleagues. Join us on our next broadcast. You could go to redislabs.com/webinars and check out what's on tap and register. Until next time, thank you, everybody.